What's up, what's up, what's up? Welcome back. Today we're working on my to-do file system, which is a file system to organize my life. The pitch is that I have tasks that I want to do. They're kind of lined out similar to how we see on the top right. Every day before stream, I say, what can I do today in a couple hours? And I write basically this, right? And what gets a little difficult is sometimes, since streams are so short, I might have like a chain of 2-hour tasks where I want to like outline what's going to happen a little bit ahead of time, so that I don't have to like stress out the morning of to be like, oh shit, I gotta think of something to do. So I need a way to track those tasks, and the simple mechanism is files on disk. And then I just put them in order. But what if I want to have like a selection of things that some block others, some don't? I'm having trouble remembering all of the ideas that I want to work on. And so I need a way to like write those down in a way where they can like be linked together, right? This thing has to happen before this thing can happen independently, etc. And so I kind of want to like visualize those things as like a tree of tasks, right? Where you could have like project, and he has like something, task A and task B, and then maybe B blocks C and C blocks D, and I just want to be able to like visualize that quickly. And so I'm thinking like, what's like the fastest way to do that? And it feels like implementing some sort of like shitty fuse file system that's essentially a view into the database of items linked to and links. Seems like that should be fairly straightforward. It's taking a little longer than I expected, but that's okay. That's part of the fun of programming, as you get to learn as you go. And so today's goal is to try to like add an interface to like create these tasks. So right now we actually have a file system where like we can kind of visualize what we want. So if I cargo run, not that cargo run my to-do fs and mount it at test mount. What happens there is if I type mount, I see to-do fs is mounted on test mount, so that's great. And if I go into that test mount, I can see like, here are all of the items I have. So I have 7 tickets right now, and each one has like a relationship to a project. So this guy also, he's part of my like image to text project, and he's saying, oh, this task blocks these 2 things. And if I go into like my project view, I can look at each of my children, and this is like a flat list of all the tasks I have available, as well as I wanted to have a view of like things that are blocked, but I don't have that. So I can look right now and see like, oh, black and white prediction blocks color prediction. Sure. Working with SIMD is blocked by working with Rust first. WASM also blocked by Rust. And so like, if I then start saying like, if I want to work on Rust, do I have like the tree command? I think I don't have it installed. Yeah, okay. So there are like Linux tools you can use to visualize the whole tree at once. And that will make my life maybe easier. Maybe, we'll see. And so what I want to do today is add an interface to create them. So right now, there's no way to like create a new thing. I can't like make dir in here. I can't like there's no interface here to create stuff. And so what we've been doing right now is we've been like hacking the database essentially to like put in the stuff that we want, and we want some form of interface to do that that's more sane for a client, me, using my Fuse file system. And I was trying to think like, what does that look like? So one option is you have like a file new, and you say like echo ticket name into new, right? And that's kind of like how sysfs kind of does things, like the Linux kernel. You have like sys class, I'm trying to find like, where's my GPU? I use this frequently. Card 0. Device? No. Device? Yeah. So here, there are like all of these like attributes, and I can say like, I can say one of the things that I do sometimes is there's like power performance level, and I might say like echo high into this thing. DPM force performance level, and that will like put my GPU into like a high power state. But the problem with this is that I don't have like any way to retrieve information about what happens here. I can return error codes that say like write failed, but it's not really like, it's not like an interactive thing. And I might want to say that I want to try to like add a relationship, and I might want to see exactly why that fails. So I want some sort of back and forth. And so that starts looking sort of like dev devices. So these guys usually are like block devices, and you like can like read and write to them, and something will happen. They have like a third channel ioctl that lets you like call functions essentially. But really it's just like pushing and pulling bytes from like a kernel driver. Which kind of like matches what I want here. I want to be able to like push something and then pull something back and say like, what did I get? But I think that block devices aren't really a good fit here, because when I looked into them briefly, it seemed like they're pretty tied to the kernel. And so option 3 is like Unix sockets, which kind of does like mirrors like a TCP socket, right? I can like read and write to it, and then I can like send some message to say like, hey, can you create me something? And then I can read back the response. If it says like error, then I'm like, oh shit, that didn't work, and I can present that. So I'm thinking that's the route we're going to go. The fourth option I was thinking of was I could like bundle a tool, just like an executable in the file system, injected in there automatically. And when I run it, I could like just modify the database directly. And I was like, I don't really want to do that because one, then I need to keep track of where like the source of the data is, and I don't really want to like expose that to the client. And two, there is no two. One was really the major reason. So I think that what we'll end up doing is we're going to expose a Unix socket through the Fuse system, bundle an executable to interact with that socket so that we can like just write like /create item, and that will like automatically do everything for us. But if we wanted to get like under the hood, then the mechanism for creation is going to be like probably JSON blobs over the socket, probably. And so I'm not actually sure right now if Fuse will allow me to create a Unix socket. So I need to try that. And so before we do that, we kind of have to understand how the fuck do Unix sockets work. So the plan of action is to like make a little hello world Unix socket demo. So maybe we'll like spin up a Unix socket server from Rust and then try to like connect to it with C. The reason I want to connect it with the C is because then we'll be using like lower level calls, and we'll be able to like guess what the Fuse side is going to want us to do. Then we can, once we have our like server and client, then we can swap out the server for one that's generated by Fuse. In our to-do file system. Then we'll have to like, once we have like connection at all, then we'll be able to like create some form of API and then bundle a tool. So that's the plan for today. That is the plan. Excited to catch the stream live. Just found the channel this weekend. Hey, glad to have you. Always thought of Unix sockets as TCP over FD. And I think that is basically what they are. I was looking at like the APIs to them, and it does look like they're like kind of like per connection things. So if you have like multiple clients connecting to the same server, they'll have like their own streams. But the only thing is, I don't know if I go into like Rust and I say like create Unix socket listener, I need to like give it like a file to create with that. And the Fuse stuff doesn't really work that way. So there might be a little bit of like juggling that we have to do to get those things to line up correctly. Might be. Okay. So let's say we are going to start on writing a Unix socket hello world. So I guess we'll just make like a quick new binary for testing. So we can, let's say like edit source bin, and we'll just call this like Unix socket dev server. And this is going to have a main like this. And we can just create a little like Unix listener, which we can look at the docs for if I can find my browser window. Here we go. Unix socket Rust. Unix SED OSNet Unix listener. This is probably what we want. So here is their little example. They say, hey, bind to a specific file path. We're going to create that file probably. Then each client is going to try to connect to us, and then we just do a thing on that. Okay, sure. So we can just probably copy paste this whole thing. It doesn't really matter. This isn't like what we're going to end up doing for real. We just need like something to interact with. So let's say that this is going to go to, we'll just make the socket in our current working directory. That seems pretty reasonable. So we'll say like test socket. Here, I guess we'll just print line found client, and then we'll do nothing for now. Maybe we'll read from him. Yeah, we'll do a quick like read and write. So we'll say stream read, no, receive maybe. What does this guy have on him? Unix stream. What does he have? Actually, in this example, did they not have reading and writing? Only getting new streams. So we need to see examples. They have write all. Certainly they have a read on here, right? Certainly. Yeah, so this guy implements IO read. I see. So we say like use std IO read. We can then read from this guy, read into some buffer, read to string. Is there just like, I can't really read to end because we don't really know, the file's not gonna like go away until we close the connection. So I guess read to string seems reasonable. So we can say mute read. Is the past tense of read spelt the same? Read past tense. Am I crazy? Does it? Oh my. Past tense of read is also read, but you just pronounce it different. That's crazy. I haven't thought about that. That's fucked. Okay, so I guess I don't want to use read as my read past tense as the variable name because that's fucking ambiguous. So let's say data string new. And we read the string, and we just shove it in the data. Boom. And we'll unwrap for now. And cannot mutate variable, so we shove a little mute on here. And we then print line read data. Data. Okay. And then we'll just write something back. Stream.write. I guess we probably need to use std IO write as well for this to work. And stream write. And can we just say like, what the fuck just happened there? Stream write, buffer a byte string of, we'll just write like hello world. Okay. So this should be enough for us to get moving. Let's cargo run. We're gonna run the new bit binary that's like, I already forgot what it's called, so we're just gonna type cargo run. It's gonna tell us Unix socket server. We need to type --bin here. And if I ls here, we have a test socket. Great. And if I... Can I just like echo test into that socket? I actually don't know if that's legal. No. No, that's not legal. Okay, so how do we like use this guy? I guess we can... Maybe we do the Rust version of the client first, and then we upgrade to the C version once we're happy with it. Maybe Netcat has a Unix socket mode. Oh yeah, that seems reasonable actually. That seems like very likely. So nc help man nc Unix socket. Yeah, so -u capital. Sure. So we have test hello nc-u test socket, and I can say like found client hello, and he got the data but he didn't send it back. So I guess how do we like, maybe using read to string is not reasonable. We can set a timeout. Otherwise it probably blocks indefinitely by default. So maybe we say maybe not. Is there a way to like mark where I expect to break? I guess we could wrap it in a buffered reader, probably. Let buff read buffered stream is equal to buff reader new of the stream. And then we can say for line in buffered stream lines. Do I need to use the buff read trait here maybe? This doesn't matter. I just want to make sure I get it, you know? Buffered stream. I think there should be like a lines thing. Yeah. Then we can print got data this. And maybe we'll write hello world before we do any of this, and then we can see both sides working correctly, probably. He doesn't like that. Because we have to write before we read. Okay. There we go, my hello world, and test. ASC. Oh, because I didn't actually print the data we wrote. Fuck. Red data line. Okay, what is line here? Line's a string, so say let line is equal to line unwrap. Okay. Arm test socket because he's in use. Okay. Hopefully this is the last time. We've got our little nc-u test socket. We got hello world. We type hello. He says hello. Perfect. Okay, cool. So we get it. I wonder if we can just strace this and maybe skip the C side. So what does he do here? Let's look for test socket. So here he just calls socket connect pull read write. Okay, so that's actually simple enough that I think that we don't need to write like a client here. That gives us like a clue. So we have to see if when we in our fuse file system, if we create a socket, a Unix socket, do we have options to like handle connect, read, and write calls? That's the question. So we can look at the libfuse docs. And let's see if we have the options that we need here. So I guess we'd have like connect. There's no connect. Maybe in the low level ops there is though. Maybe it gets mapped to like open. Fuse low level. Here we go. So they have low level ops. Do they have connect in here? No. I don't know if this is possible. Socket. Oh, create a regular character or socket node. Okay, so make node exists. Open. Maybe it will turn into open. We do have read and write, so I don't really see why it wouldn't work unless it's just totally unsupported. I guess we just try it and see what happens. Okay. So what does this look like? If we want to create a socket in our like fake file system, we would go into our fuse stuff and I guess the first thing we do is we have to list it somewhere. So somewhere in our like client code, we generate directory entries based off of like where the person has tried to read from. So I guess we just say that if somebody reads at the root path, readdir, oopsies, I went to the wrong spot. This is in client. So if somebody calls readdir, we will just say that one of the things that we'll return is a dir entry, and we'll call it socket with the name test socket. Okay, which means that we have to then say that we have a socket type. This. Okay, and this guy has to be an OS string, I guess. Okay. And then when they call get adder, what happens when they call get adder on it? So we have fuse client, fuse mod here. And we have get adder, which is where we should be setting that we are a socket, which means that I guess somewhere we have file type socket needs to go here. If we're a socket, we flag ourselves as a SIF sock with probably 644 permissions. Probably makes sense. Which means here we also need to handle socket, name goes name. Okay, and then what? So when we call getAttr, we say get the file type of this thing. Okay, and here we parse the path, right? And here we just have a bunch of filters to say like, oh, depending on what path you pass in, here is, depending on what path you pass in, I will figure out what you wanted from that. Which is kind of fucking stupid, by the way. This should be like shared code with the code that generates the listings of the directory, but it's not. And that causes some problems. And I'm probably gonna have to fix that at some point. But for now, we'll just put it in another fucking case. If path is equal to path new test socket for now, we say that we return the path purpose socket. Sure. Fuck it. Fuck it. Which doesn't exist yet, so we just add a socket thing here. What is he complaining about? Expected semicolon? Oh, because I forgot this. There we go. Okay. And then when they say, what file type are you? When I say path purpose socket, I should just say, okay, file type socket. And file type is lowercase t. You might want 666 on the permissions. Yeah, I could see that. And then here, if we are trying to list a directory, then we can say, if we are a socket, we're not a fucking directory. Boom. Boom, boom, boom. Okay, cargo check. Everything probably compiles, nice. And then we can mount our file system. We can run our to-do fs. And now when I ls test mount, hopefully I see a test socket here, which is good. And now we can see what the fuck happens if I call netcat-u on test mount test socket. Does it like, how badly does it shit the bed? Fuck. Maybe kind of bad. Connection refused. That's not good. I was kind of hoping that I could see some form of like call here that wasn't implemented. But it does seem like they just call getAttr and then probably the connect call is just not passing through to fuse. Probably. Let's see strace-f. Where does this econ refuse? Comes from the connect call. Fuck. That sucks. That sucks. Okay, so what's another option? What is another option here? Nothing's calling bind on the socket first, that's why it's refused. Yeah, but like, oh. No, I could see that maybe. Yeah, so maybe on our side, maybe we like, I wonder if we can start a listener on that. Maybe. That seems like kind of fucking nuts. But it's possible, right? So maybe the like syscall for connect is checking if anybody has bound a listener to that path. And nobody has. So I have to. Maybe. That seems wacky. But we can try it. So let's go to our main here. And this guy, he runs the Fuse client. And maybe just before we do that, or after we do that, if we have a Fuse client, we are letting Fuse parse what the path is, which is annoying. Which is a little annoying because we don't know anymore. I guess we can maybe look at our options in here. Okay, let's for now just hard code it because we know what it is. And I wonder if I say once this client, maybe we call like an initializer on this guy. So I think that you can bind. Oh, here, we create our client here. So maybe we just may say function new. In our client, one of the things that we're going to have. Let's think about this. I guess we'll just start a listener here. Fuck it. Okay. So his input is going to be a database for now. He's going to return use client DB. And just before he does that, he's going to create a listener on that path. So we'll say Unix listener. Actually, maybe we look at the server side of this as well. Let's do that. Let's see what happens when we run our Unix socket server test. Let's rm test socket. Say target debug Unix socket server and strace that. Okay, so what does he do to create that guy? He creates a socket. Then he binds to the test socket path. And then he calls listen and accept. Nothing crazy there. Nothing crazy. So what happens if like a file exists? Like is bind what's creating it? Unix socket. So eaccess, not existent interface, fault, blah blah blah, no memory, not a dir, component path prefix, not a directory. It seems sketchy, but I guess we just fucking try it. So we say what? We check that this guy just calls socket and bind. Seems reasonable. So here, can we just say that we want to create a Unix listener? So we'll start a new thread, I guess. Yeah, sure. And he will just say that at test mount Unix listener new, and ooh, that's a good test. You're right. If netcat can listen on the fake socket, then that indicates that this would work. That's a good idea. Good idea. Cargo run. So without having to do any extra work, we can just say nc-ul what am I looking for? testdb2. nc-ul testdb2. Nope, test mount. And then we have test socket. Address already in use. That's interesting. So what happens if I strace -f? So he tries to bind, and when he tries to bind to it, then it says that that's in use already. Which kind of indicates this whole concept isn't going to work. Okay, so I wonder if there's like, can we create a block device instead? Fuse block device. Maybe that's... is that something that we can do? What is this guy doing? Fuse block device. A virtual block device backed by Fuse. That's... oh, interesting. So he creates a Fuse thing that you can just read and write on. I wonder if we just create a normal file. We could just maybe create a file that we read and write to. And maybe that behaves almost the same to the point where it works fine. So let's try that. Let's say, we'll say that our socket thing is just going to be a file. And And here, we'll call this file. Okay, and then back in our fuse stuff where we flag what it is, we will say somewhere in here. This guy, we're going to say file, and here we're going to say if reg. Which is kind of shit, but it is what it is. And then, so let's think. So if I then try to go to test mount ls, I have test socket. And I guess I want to know if I like write and read to this what happens. So we can say echo test into test socket. So that, oh, sorry. Let's go back one. Let's go up one, echo test into test mount test socket. So he calls open, which is unimplemented open for test socket, which is fine. And I guess we can just implement that and see what happens. I wonder if we get like unique file ID, like if we get like a unique handle from this, then someone could call open, write, and read, and we could correlate that back with who called the write, and then this would behave just exactly the same. So let's try that, and we'll say that this kind of failed, and we're going to say we're on a new path of investigation, which is add a socket-like file to the file system. And let's just see where that takes us. Finally, something I can lurk too. Linux plus Rust plus Nix, rare find. Yeah, I doubt that that's common. Maybe it's more common than you'd think. I wonder if like there's a high correlation of people who are into Rust and people who would be into Nix. That seems like the type of thing that would have higher than average correlation at the very least. At least a higher correlation than people who are into soccer and people who are into Nix. Okay, so like I guess we have unimplemented open. And we will just say that I guess we will go into our client and we'll just say client.open. Sure. Or maybe we'll just see what do we get in here. What is in this info thing? We have flags, file handle, lock owner. Is anything in here like an identifier for my file descriptor? I guess I get to make one. Okay, yeah, sure. So let's say theoretically, let's just say for now that we inject a file descriptor, and we get to pick that number. Then we probably get it back when somebody writes to us, and I wonder if that gives us like some sort of link for who we're talking to. So we could say, what, static? Where do I want to hold state right now? I guess we can just hold in the client. Static. Fuck it. Well, static counter is a atomic I32 equals atomic I32 new. Can this be created? Yes, okay. Then we'll say let ID is equal to static or counter fetch add 1. Okay. And probably we need to specify like an atomic ordering in here. Ordering, I don't really care. Relaxed seems reasonable. Fuck! Language server crashed. So we nvim mod. You trying to make up the FD that would be unique to the opening process. Otherwise, you could clobber their students, etc. I think that the file descriptor. I'm trying to just see. So how do I say this? I could imagine a world where somebody calls open on me. They get a unique file ID for them. But I don't know if I know what their file handle is, or if it's like two processes could both open me and they could both get the same number. And I want to know if like I get to determine what their number is, if that makes sense, or if I get like a handle that's like per client. I'm not really sure, so I just want to see. So use ordering relaxed, okay. And if I just say info dot file handles equal to ID, as U64, I guess, and then return 0 here. When I write back, I want to know if I get that. So I guess we can look at on write. We can look at our info. So you can say print line info. So file handle is this. And then we just say info fh. And I have to put brackets around this. Okay. So if I echo test into this, I got file handle 0. Echo test into that. File handle 1, 2, 3, 4, 5. So I am seeing like unique. I think that this means that I have like a way to negotiate who I'm talking to, which means that if two people open me, I can probably like treat them as two separate files, even though that like from their perspective it's the same file, I guess. Which works for me. What works for me? Okay, so what are we gonna do? I guess in our client we will track. We will track people who have called open to us. So somewhere there's a fuse client struct in here. I can just say open files is going to be like a hash map. Yeah, fuck it. Hash map of U64s to read write handles. Does that make sense? Let's think. I guess so. Somebody's going to call write to me. I'm going to do some operation with that. And then I'm going to try to respond back to them. So I guess the only thing that I really need is like a buffer of bytes to send to them when they read me. Yeah, so I'll have like a vec deque. Does it need to be a vec deque? On read, I can just clear it no matter what. But I guess it depends on how many bytes they read. So sure, yeah, we'll have a vec deque of U8s. Double-ended Q, vec dq. Double-ended d. Why is this how it's capitalized? I would think it's like DEQ or something. Capital E, capital Q, but whatever. Okay, fuck it. We're getting distracted. So let's say that we have a vec deque here. And now open files is just a empty thing. Okay. And so when somebody opens me, I can say, well, let me check what your ID is. And if they read from me, then I will like basically just pop some amount from here. So that means that we need a pub function open, which takes in self and a bunch of other stuff that we haven't decided yet. Isn't there already a buff reader writer that would do that for you? But I think that those like buff readers and writers like wrap something that implements read or write. We could do like a channel or something, but I don't see any reason why like I would go through the overhead there. Because I don't have like some interface that I'm trying to fulfill. I don't think. Because this is going into like fuse C bindings. Vec DQ implements read write? Oh, that's pretty funny. Okay, so I just happened to take... Okay, I stumbled onto the right answer, maybe. But like, because what I kind of want is like a channel. But the reader of the channel doesn't know they're a channel, right? It's like just a C call that's saying read, and I have to like interpret that however I want. So it doesn't really matter what the data type is as long as it like makes sense, I guess. Okay, so he is going to return a U64. That was my biggest PR to Rust a while ago. Oh, that's pretty cool. That's sick. Is that Rust vectq read write. Can we find you on GitHub? How do we like even like? Is it easy to tie this stuff back? Impl read. Does this even trait implementations? Implements read from 1.63. Rust 1.63 changelog. I'm curious now. Stabilized APIs. vectq. It's not in here. Okay. Well, I believe you. I was hoping I could find it to shine a little light, but it's too hard, so fuck it. Okay. So path. He's going to give me some path. I'm going to parse the path. Right? Self parse path. And I guess the only thing that I'm going to handle right now, this is my PR. Sick. Cool. That's cool. I've never contributed to Rust, but it seems fun. How did you decide? Like, what's the process right like there? Like, did you have to write like an RFC and shit? It was really stressful, self-imposed. Like, here you just kind of say like, I did the thing. But does that not mean, like, do you not need to like create an RFC and stuff? Oh, okay, cool. No RFC if it's a small change. Cool. That's pretty sick. Congrats. Okay, so here, if I have a socket, then I'm going to do some stuff. Otherwise, I'm going to continue on and do something of value. Oh no, sorry. Otherwise, I'm going to return. I guess none. Sure. So we can say, hey, open this thing, and if you get a file handle, then I will use that. Otherwise, I'll say that open failed. Okay. Then we can, I guess we want to track what the last ID we had was. So latest open ID is a U64. We'll start with 0. Maybe we have to start at like 3 or something so that we don't like collide with standard input and output. I guess they probably won't get the same ID that we assign them, so we can just stay 0. This is probably an internal tracking thing. Probably, maybe. Who fucking knows? I don't. But we're guessing. And so then we will say self open files. This is going to have to be mutable. We're going to insert the last open ID and just create a new vectq here. Okay. And then we'll increment the open ID. Okay. And then I guess we return the ID. Okay. This also has to, this is like failable because parsing the path can fail with a parse path error. So we can just say result parse path error. All right. And so this has to be okay some, and this has to be okay none. Okay, none. And that's probably it. And then when they call read, we are now going to call read with the file ID, and we are going to return. We could like return a slice of shit that we pull out, or we could fill the buffer directly. And I guess we don't really know what their inputs are going to be yet because we haven't read that part yet. So maybe it makes sense to just continue on by stitching the open stuff together, and then we can come back to read later. So here, when they call open, we are not going to use this counter anymore. We're going to say if let sum, no, match. Yeah, match client open, and we are going to try to open the path. So we're going to have the Rust path. Okay. If it's okay, none, we are going to return, we're going to say error unhandled open for Rust path. Okay, and then return -1. If they get a number, so we'll say ID, we're going to assign that to info. And return 0. Probably. And if we get an error, we'll say failed to open Rust path. And we'll write the reason as E. Okay. We're close. I don't know why. I always put this like arrow here, which isn't supposed to go there. I just do that often. This should be some ID here. Okay, some. All right. And now, probably that runs. Nope, because 382. Here we have to call fuse client new with the DB. New is private. Okay, so pub function new, I guess. Cool. And now, if I echo test here, it looks like everything worked there. I think we're supposed to free this guy on flush, if I remember correctly. I think it says that we're going to call flush exactly 1 time per open, I think. So we can look at libfuse docs. Libfuse docs. And we can go to the fuse header, which is somewhere here. And operations. Flush. Hello, flush. Here we go. Possibly flush cache data. Flush is called on each close of a file descriptor, as opposed to a release, which is called the close of the last file descriptor for a file. Under Linux, errors returned by flush. Okay, so maybe we want release. Release is called when there are no more references to an open file. For every open, there will be exactly 1 release with same flags as the file handle. It is possible to have a file open more than once, in which case the last release will mean that there are no more reads and writes that will happen on that file. So I guess like if you like duplicate a file descriptor, then you could have multiple flushes in 1 release. Okay. So I guess we just have to implement release. It's to clean up our shit, you know? But I guess doing that now doesn't make sense until we understand if the approach will work. So let's just handle write and truncate and shit first. So, he warned that there was an unimplemented truncate. Then he tried to call write, and the write failed. Okay, so let's look at write. Fuse client write. Okay. So what do we do here? Right now, we assume that there will be a pass-through. The only thing that we can write right now is to like the underlying data that we're supposed to be mirroring. But now that's not true because we have this other special case. So we can just put all this into let pass-through path is equal to client get pass-through path for the Rust path. And we can say let Rust path is equal to C to Rust path. Okay. Then we just put all of this into a if block. Bump, bump. Like this. And otherwise, we return -1 or something. Okay. If let this is okay sum is this. I guess we should probably handle errors here. So we can say, fuck it, fix me, handle errors. Again, we just want to see if the process is going to work at all. So, if we then find out that it's not a pass-through path, then we're gonna have to call client.write. Sure. That makes sense. And if we call write, what are we going to pass through? We're going to pass in a buffer and a size and an offset. All right. So I guess it makes sense to turn the buffer into a slice because the client kind of works in like Rust code land, not C code land. So we're going to say let buff, Rust buff is equal to stood slice from raw parts mute, and we'll pass in the buffer and the size. Buffer and size. I think that should just work. So this type doesn't resolve. Arguments of this function are incorrect, so he expects a data, star mute t, and len. Buff is a star const. Fuck off. Okay. Let buff is equal to buff as mute ccar. Otherwise, this won't work. What's the offset for? I assume the offset is how far into the file we're trying to read. But not sure. Not sure, actually. Let's see. Write. We are looking for write. Offset. Doesn't really say, huh? We could look at the... well, what do we do for the pass-through case? We call pwrite with the offset. So let's just look at like man2 pwrite. What is offset? Writes up to count bytes from the buffer starting at buff to the file descriptor fd at offset. The file offset is not changed. Yeah, okay. So I guess they're expecting that we are not tracking how much of the file that they've read. Which means... which is kind of fucked for us, actually. Wait up, that's the right handler. You shouldn't make that pointer mute, I don't think. Oh, that's for read. That's a really good point. That's a good point. Very, very good point. I thought I was implementing read, but you're right. I am implementing write. So this should just be from raw parts. And then we can set call client.write Rust buff. Okay. And I guess we don't really have an implementation for this yet, so I guess we'll just keep this in. And what I actually wanted to do was I wanted to do all of this in read. So we'll just apply the same thing to read, and we'll just, for now, say this fails. Okay. Fuck it. We'll implement write. We'll do it now. So what does write look like? For now, let's make a little echo server just for testing so that we can understand. So we'll just say that on write, we take in a buffer, which is a byte slice of U8. And for now, all we will do is we will say self.open files, get, we need the ID here. And then, we will say, what will we do? We will just put the stuff in there. Self, so we'll say let f is equal to this. You have to say get mute, yep. And then we can say f extend with buffer. Put the shit that we get in there. Okay. Simple, simple. And so here we need to take the file handle, use that as the ID. Okay. And then this guy needs to be as const u8 instead of const i8 because Rust likes unsigned bytes for their IO stuff, and C likes signed, but it doesn't fucking matter. Okay, and now we do the same thing. This guy, I guess, returns... What does he expect us to return? Exactly the number of bytes requested, except on error. Okay. So we return size. Try into dot expect failed to cast size to either 2. Okay. Yeah, sure. So now if I run this, we should see echo test here. That succeeds, and if I cat this, nothing comes out. But if we were to try to open, write, and read within the same process, hopefully we'll get back what we want, assuming that we implement the read side. Okay, so on the read side, we're going to apply the same treatment here that we do this error handling shit. We get the client, the Rust path, get the pass-through path, and all of this only happens in the case where we get the pass-through path. Otherwise, we do our new path, which is client read with the info file handle. And then we're going to want to write that into the Rust buffer. Okay. And then we say that the Rust buff is a stood slice from raw parts mute. And what happens here? What happens here? We pass in the buffer as mute u8 and the length, which we called size here. And Rust buff should be a mutable u8 slice. Nice. We don't have a read function yet, but that's okay. And pub function read, it's in mute self, ID u64, and a buffer, which is mute u8. Okay. And then we get the thing. Yep. Let f equal this. And we just write from f into buffer. So f.read exact buff. Sure. No method read exact found. Am I high? Cargo check. It's supposed to. I thought that that's from read. Oh, I didn't pull in std.io read. That's why. Okay. We're close. We're close. Here, we were supposed to pass in Rust path with an ampersand for these guys. Maybe not there. 301. Ah, here they want pass-through path. Oops. Oops, oops, oops. And then here I'm supposed to return something, probably size. Try into dot expect failed to cast size to either 2. Okay. And expected blah. So in the client, we just have to unwrap here, and then everyone should be chill. Cool. Okay. So here, if I echo test into that and then cat him back, we get nothing, as expected. And then we should just write a shitty little program that opens the file as read-write. And hopefully if we write something to it and then read it back, we get the same thing back. So int main void. We say what? Int f is equal to open test mount test socket read write. I think we need f open for this to work. gcc-o test test.c. He doesn't like that I didn't include stdio. Okay. Returns a file star. So this is file star this. Okay. F right. What's the signature of F right? Man, F right. We pass pointer, size, number of elements. Okay, so each of size by itself. Okay, cool. So we say like test 1, 5. We forgot to pass in the file probably, which is the last item, F. And then F read, F. Man, F read. The function F read is pointer, size, number of elements. So we just have the output here. So we say buff. What do we want to do? We want to say like, I've forgotten my C syntax. uint8t car. That's a labor car output, and we'll just say that this is 5 things wrong. And we read output 1, 5 from F. And we just print line, not print line, god damn, print F, string, output. And maybe we say this is going to be 6 long, and we just set everything to 0 to make sure that we don't go past the end of the world here. gcc-test.c, run test, we got nothing. So here, what happens when we run test? We open test socket once. I don't see any write there, actually. Why not? Am I not supposed to see man to F write? Man, F write. Do I have to flush in between or something? Because I'm not really seeing the write call happen. Am I high? strace test. Write. Open? So I'm seeing an open and then a read? Why don't I see the write? Open for reading and writing. Oh, I just used the wrong fucking string. It's R+, not RW. Hello, what about the fuck's going on? R+. GCC, test, and strace test. Do I see the write call now? I do see the write call. Okay. And here, we're getting a write flush. Do I see the read in here? No. But it does look like we're kind of close. So let's go back over here and just double check. Let's at least see if we'll get the read call here. So we'll say read file handle here and write file handle here. Write file handle here. Need to flush? Seems possible. Definitely seems possible, but so we got a write file handle here. No read happens. Try flushing before reading. But like I should see a read no matter what. Like I'm just not seeing that like I'm calling read on this thing. And the read call isn't coming through. So I've made a mistake somewhere. Fuse client read. This is in here. Something's odd here. Something is definitely odd. Flush. Right. Let's run this again. And just call test on it and like just make sure that I'm not missing anything crazy. So they open, sure, right, get attr, interesting, flush, okay, then release. So why is the read call just not coming in? Maybe because on open I might not have set the file permissions on my side correctly. like, do I need to let Fuse know that this thing is readable and writable? Right? Like, maybe I need to set the flags on this guy. Maybe. Flag equal to sys o re o write o read write. Let's just see. That's like a real shot in the dark. But maybe. You know, you never know. I just don't see. All of the uniques are different. Is that your ID? I think no. I think that the thing that we're seeing in the square brackets is the ID I'm trying to use. So open 2, write 2, flush 2. Why the fuck isn't it calling read? Okay, let's try opening this thing as read only and only calling read on it and see if that makes it through. gcc-o test. Test. Open. Yeah, there's something fucked here. So even then, it's not happening. Is read in your obs a little? It should be. Especially because, like, a good test for this is if I cat test mount items 1 content. Oh, there's no thing in here. So we'll say echo test into here. Fuck, not permitted. We must have fucked something up. But that's interesting. Because this didn't used to fail. I used to be able to do this. So we'll say echo test into testdb 2. I think that's the one we have mounted. Items 1 ASDF. Okay, so this works. And if we cat this from the database, that happens. And if we cat this from the mount, items 1 content items 1 content ASDF. See, like, the read is hooked up because we are seeing it get, like, piped through to the source operating system. And here we're seeing the read come in. So why is this different? Why is this different? Well, let's try catting test mount test socket. And okay, so that's a good clue. Is that we're not even, when we cat one thing, we see the read call command. We cat the other thing, it doesn't. So here, when we cat this thing that works, we have open with flags here. And when we call this guy, he has open with flags. The flags are different, which is interesting. Let's look at man to open. Flags. What does he expect? That's not helpful. This is not helpful because it doesn't tell me the numbers. It does not tell me the numbers. I feel like I'm missing something just like really fucking obvious. So let's look at this again. It could be like the return code here might be wrong. What do we do in the pass-through case? We return 0. And we assign a file handle to the thing. Okay, and we pass in the flags. Maybe open is setting flags on here? Man to open. Nope, flags is nothing here. Is just a integer. Okay, so he's not doing anything special. He's not doing anything special at all. Possible that maybe fread is not doing what I expect. So let's go into my test.c. Yeah, we'll do this. We'll mount the thing again. We'll go into test.c. And we'll try, instead of opening this, to open items 1 content ASDF. And see if we get something out of it. gcc-o test. Test.c. We run test. Okay, so we do actually get to the read call here as well. So why is it different if I call it on test socket? Like, that doesn't make any sense. It must be related to... okay. We're going back to this, compiling, running. When we call this, we open, we get flags 0x8000, which feels different than what I'm getting when I run on the new file. Let's ls-l test mount and see if, like, here we have rwrr, and if I ls-l test mount items 1 content, oh! This isn't readable by me, technically, because it thinks it's owned by root. And I'm not the root user. Ah, okay. So, once upon a time, somebody said, shouldn't you write, like, what if you wrote 666 and says 644? And maybe they were right. Let's just try that and see if it behaves differently. So this was test mount, test socket, r plus, write test, read test. And we run test. Fuck me. We still get the write. We still don't get the read. Why? Why? I feel like I'm high. I feel like nothing crazy... We're not doing anything wild here. We're just calling open and read. And... okay, maybe we'll run strace to see if we can get some clues on what the difference is here. So content, items, 1 ASDF. This is the one that was working. GCC-O test SLC and test. Oh, wait. No, here. Okay. Oh. Wasn't this working before? Cat this. Oh, fuck. We accidentally turned this into a directory at some point? Am I high? Oh, test db2 items 1 ASDF. Okay. Test mount. Cat test mount content items 1 ASDF. Why does he think he's a directory now? What changed? Hello? Oh! I'm an idiot, that's what. This is contents in the wrong spot. It's items 1, content, ASDF. Okay, cool. And so here, I don't know why I had it like that way. Content. GCC-O test. This gets it. strace-f test. So he calls open at with, nope, wrong thing. Open. ASDF. We'll search for ASDF. Am I fucking high? Oh, I forgot the dot slash, so it was calling the wrong executable. That makes a lot more sense. Okay, so we call open with O read only. And he returns 3. Okay. Then we call read on 3. Okay. So when I call this on test socket, we call open. He returns 3. We read 3. What the fuck is the difference? I feel like I'm losing my mind. Oh, wait, hold on. This does return 0. Hold on. Is it possible that there are multiple paths here that we could end up in? Let's see. Let's see. No. Because when we call open, I feel like I'm losing my mind. When we call open, we get back a file descriptor. We do call, what is this new fstat for? Maybe this is relevant. That seems possible. I wonder if maybe we'll kind of downgrade a little bit from fopen to open, just in case it's doing something wacky. So where do we man to open? We have, it's from fcntl. And we are now going to call this with o read only. Read only. O read. Oh yeah, o rd only. Okay, so that makes sense. Then instead of calling read, we call fread, we call read. And he just passes in a buff and a count. So we say read fd output 5. Okay. And let's see if this behaves any differently. Man to read, so he comes from unistd. Okay. And we call test. We are not running anything, so we call test. It's still, okay, so that's interesting. So he's still, now he's just calling open at and read. I wonder if we're not going, I wonder if this, we're not getting like the right open call. We could check that. Fuse client open. So here we should say print line. Why is this telling me to, oh, return, that's fine, okay. So here, print line. Got open request for this. We cargo run test. Got open request for pointer, fuck. But it does mean that we're in this open path. Unique code flush. Dude, I feel like I'm losing it. Again, because if I go in here and I change this to tests mount, items, one, content, ASDF, why does it behave any fucking differently? strace test. Right, we're doing the same shit. We call open and read and it just behaves different. Because here the only thing I can think of is that these flags are different. So can we, let's just, for shits and gigs, write this. Just for shits and giggles, just because I want to see. So here we go back to, we're trying to open our fake socket. Okay, so what the fuck is the difference, man? I don't get it. I don't understand why the read call just isn't making it. Is there maybe a hello world libfuse? Surely they have a read write example in here. So they have open. When they open, they don't do shit. Don't you have to pass in the buffer as a reference, or is car an implicit pointer? Car is an implicit pointer. So it's working when the thing that's bothering me is that it works when I pass it to, like, when I'm calling a normal file. So there's a piece here where the fuse side just is ignoring my request for some fucking reason. And I'm not understanding it. I'm not understanding it. This might be relevant, where maybe they think that the size of my fake ass file is 0. And so they're just not executing the read. I do have different enum variants for the fake socket and pass-through files. Yeah, so it does make sense that like it's taking different values. I just don't understand why. I don't understand why. But yeah, let's try and get attr saying that my size is different. Because here we're just calling through. And so this guy's saying that in his hello world example, he is setting this. So we'll try setting that. So here, when we're a file, we will say that the st size is equal to 5 or something. Like, just so that it's non-zero. Oh, fuck yes. Oh, that's so frustrating. Okay, so now we're at least fucking getting in there, which is massive. That's huge for us. That is huge for us. Okay, so it looks like this is important. st size. Which feels fucked. It doesn't feel like libfuse doing too much magic behind the scenes. Yeah, it does feel that way. It feels like there's like, this is not the right way to do it. But I guess we'll just continue on and see what happens, because I'm curious now. So failed to fill whole buffer. So he called, I guess here, we can say, I don't know what to do here. Because setting this to like anything dynamic, I guess that seems reasonable. So if somebody calls get attr, we are supposed to report the size of our file, and we just report it like if it changes as the file is being modified. Is that fair? Maybe it is. I'm trying to remember what we did before. We tried the socket version. That denied us on connect. There was no connect call in libfuse, so that was a reasonable thing to stop investigation on. I wanted to know if there is a like make node equivalent. So they have an ioctl thing here, which is interesting. This is probably closer to what I want. So what do they do for ioctl? When they call get attr, they return back directory or regular, and then are they just calling ioctl on the regular file? If so, then it's what we're doing makes sense, I think. So when they call ioctl, usually you would call this on a block device, but they are just calling this on the file, it looks like. Yeah, it does look like that. This example illustrates how to write a fuse file system that can process a restricted set of ioctls. It can be tested with ioctl client. So they call ioctl on fd, where fd comes from something. Open the argument. Yeah, okay. So it looks like we're on an okay path. So in this ioctl example, do they set the size of the file at all? They set it to FIOC size, which is something that they're allowing you to set externally. Okay. For now, let's just set the size to 1 and see if that kind of gives us the right thing. Because then at least read should call us with, it shouldn't like take this optimized like, oh, your file is 0 size, so I'm not even going to try to fucking read you path. And let's try again. So we call write and read back to back. He doesn't like that this is wrong now, so we switched from using fwrite to fread to read. So let's just look up man to write to do the equivalent. fd buff count. So this should be read right now. We should be looking at fd test 5. And now hopefully, right, we also have to run our file system. Okay, so we got our write. We're back to not getting our read, which is fucked up. Is it because we can only read if getAtter thinks that it's shorter than it is or something? Why is this just not working again? Fuck me, man. Why? So if I go back to read only, does this start working in? Yes. Yes, it does. And if I try to read with 5 bytes here, cargo run. Ugh. Umount. Cargo run. gcc-o-test.c. Yeah, it's interesting. So if I read this as read write, does that just not work anymore? And if so, why? Oh no, so that's working too. Okay, so that's calling read at least. If I open it read write and then directly do a read. Okay. So then why does this write thing on there change anything? Right? Like we're now getting a write file handler, getting attributes on test socket. I wonder if... No, I'm not understanding. getAtter is doing something odd, maybe? Man strace-f test. So he is writing a thing, reading a thing, and that's turning into getAtter under the hood. So there's something fucking wrong here. Maybe the fuse low-level ops is doing something fucking stupid under the hood. Like the fuse adapter might be doing something like stupid. Or maybe not stupid, at least unexpected to me. So we've looked at this before and we saw that like fuse fs right. We've seen that like there's a low, basically when you like bind to the high-level API, it's using the low-level API under the hood. And then like, how do I say this? It's using the low-level API to implement the high-level one. So someone's calling getAtter in a situation I don't expect. And so maybe we can look at like fuse fs read. Maybe will give us a clue. So does somebody use this? Fuse fs read. Where do we bind the operations again? Oh, fuck, it's been a second. Somebody creates low-level operations in here. Here. And so somebody's calling do read. And then somebody binds this read to something here. No, not here. Here. So somebody binds these low-level ops to fuse lib read. And he's not doing anything crazy. I guess the logging that we're seeing is saying that he's calling getAtter. So where is that coming from? I guess this just comes from the thing. So if I call fuse lib read, is it doing something stupid where it's like skipping a read in some cases? So if we have read or read buff, they log read. So we're not even making it here because we're not seeing this read log. Okay. So get path null okay. What is this saying? Because there is a case where we could skip the read. Is that the only case where we skip the read? Could be, could be. Who calls fuse lib read again? Fuse lib read calls this ops read, which is this. So he calls op read. Okay. And then somebody is looking for the fuse read op, probably. Fuse read. Somebody in here must be calling get adder when we didn't expect. Must be. But I'm not seeing it. Fuse fs read buff. Calls read here, calls read buff here. We don't see this read log, which we do see in the successful case, I think. Read here. Read square bracket bytes from. So here we're saying read square bracket bytes from. So that's this log. So we just must not be getting here. Which means that this get path null okay must be related. So we can look for int get path null okay. What does he do? Get path common. Okay. Int get path common. Try get path. Int try get path. I don't look up. No, yeah, I don't see anything crazy. Like, he shouldn't be returning that he failed in any way. Yeah, I'm just not seeing it. Is there documentation? libfuse read not called. Somebody must be hitting this. Okay, so this is... He's seeing the same thing as us. Where get attr, return size is 0, so read call, output empty, even though the read... Yeah, okay. But... why after a write? Oh, maybe we fucked up the permissions. We did fuck up those permissions on purpose earlier, actually. Because we weren't sure. So can we just not set those? And maybe then see if that... Maybe we fucked up when we did that. Oops, we want to go to our to-do fs again. And we're still not getting the fucking read call. I'm gonna lose my mind, man. I'm actually gonna lose it. Like, why is this get adder calling again? And why is it not doing what we expect? Right? Like, we should be saying, like, if I say like 9999 here or something, like, what the fuck? Okay. So, for some reason, the file size, the size of that is relevant in some way, I guess. And we also notice here that get attr isn't even logged in the call anymore here. So there's something fucked going on. Something absolutely fucked that we just don't understand. So he calls getAttr once at the beginning, then there's like a write and a read. And only after the read doesn't, like if the read doesn't work, we then get a log to getAttr? Like, what? Why? That makes no sense. Unless there's some sort of like fallback path here where they call getAttr on the like the case where something doesn't work. GetAttr. Come on, man. Somebody's got to give me a clue. Someone's got to give me a clue here. Because I don't understand. GetAttr must be coming from your libviews trying to be useful. It's not from your C test. But yeah, I'm pretty fucking positive as well. Yeah. So it's like, okay, so where we know for sure that read log can happen. If that read log happens, then the getAttr log doesn't happen, which means we can go to that fuse fs read, and that's like a good place to start, right? If this log happens, then the getAttr one doesn't. And so we could maybe assume that like whoever's supposed to call fuse fs read is fucking up in some way. Which means that like, fuck, fuse fs read. Like someone is trying to call. Well, okay, I guess maybe this log could be duplicated. So we could look for read square bracket. Aha! Okay, so it also that log also shows up in read buff. As well. Okay. So fuse fs read buff could be the path we're on. And who calls that guy? Fuse lib read. Okay. And who is in that getAttr log path? It's just this guy, fuse fs getAttr. So here. Aha! Okay. So lookup path is calling fuse fs getAttr. And that's lookup path is maybe only happening in the case in like some fucked up failure case. Okay. So you can go back to the fuse fs read path thing. Fuse lib read. Get path null okay. Probably has a lookup path in there. We could check if null path okay is fair. We could try setting that as a test. Here he goes into get path common. Try get path. Surely somewhere in here we get it to lookup node, which might be a lookup path. Not sure. I would just bet that it's something related to that path. So we could try, if we say get path null okay, he says there's like a configuration that says null okay. I think we saw that. So maybe we try setting this null path okay and seeing if that changes the behavior at all. Because I don't feel like we can just ignore the problem because I'm so far from understanding what it is. So is there like, where does that conf come from? Is that something that we're allowed to set? fuse config, null path okay. Oh, what else is in here though? Anything in here that looks related? No. Okay, so how do we set the configuration? How do we set the configuration? Must be on, direct IO. This disables use of the page cache in the kernel for this file system. Each read or write call will initiate one or more read or write operations. Data will not be cached in the kernel. That does sound like what we want, hey? That's a good eye. Good eye there. Okay, so somewhere we must be able to set a fuse configuration. Surely. Probably there's like, I think I've seen an init call in the fuse operations. Init lets us set the configs. Nice. Okay. So we're going to say ops.init is equal to some fuse client init. We're going to go in here. We're going to fucking copy this. We're going to paste it here. We're going to call this fuse client init. No. Why doesn't he have the extra thing on him? Why does he have the config? No. Does this guy have the config in him? Why? Am I high? Why does this not exist in our version? Maybe this only happened in some version of the file, so we can look for init. Fuse operations init. Basic fuse API. Why is this not what we see? Why? Fuse operations init. What the fuck? Is this just a different version? Might be. It might be that we just don't have fuse config in our version of fuse. Oh, but we do have direct IO in the fuse file info. Okay, wait, let's try that. Let's try that. And if that works, that will give us some form of clue. It would be nice to bypass libfuse helpfulness. Yeah, dude, for real. It sucks because I feel like it would be fine. I wouldn't care if it wasn't so hard for me to grok what the fuck is actually going on. But I mean, I understand that, you know, you write code and I can't ever really complain if open source code doesn't document well, because it's like, I don't know, I wouldn't. Like, I wouldn't either. Usually I'm happy to just like browse the source code and be like, okay, I'll figure it out. But this one's taken me some fucking time. Okay. So now it's working. So that was a really good eye on direct IO. Thank you for that. That's huge. And so now, well, let's double check that test.c. So this is reading and writing the test socket. And we are getting back. Okay, and just to double check, one more double check here, is if we go into our fuse client, and here, instead of doing this, we just say buff equals test and O equals, can you do this? I think it might be buff copy from slice test and O. Like this. There. Well, let's try, or instead of writing test, we'll write ASDF, just to make sure that we are, in fact, reading and writing what we expect to be reading and writing. Just source does not match destination length. Oops. Oops. So we don't want the O here. Umount But that's a good indication that this is, in fact... Fuck me. Okay. Okay. Looks reasonable. Looks reasonable. Looks reasonable. Okay, so all of that to just get a fucking file handle that we can read and write. And that ate up just an insane amount of time. So, do I want to keep going right now? That's the question. Because we're at an hour and 45 minutes in, and we've just been struggling. The next part is pretty straightforward. It's just creating an API to pass the stuff through. So, like here, we're gonna have to say in write parse request, then do something in DB, check result, and write response to the associated buffer. And then here, we're going to have to read from that buffer. And so I think that that's enough, because then we're also going to want to write like some executables that like wrap this stuff for us. So I think that is enough for another stream. Definitely more than 15 minutes. I think we're probably at like at least another hour, probably up to 2 hours of work. Next step is just 30, definitely part of it for sure. Okay, so I think I'm going to call it there. That took way fucking longer than I thought. I kind of thought that we would just be able to like stick a Unix socket in there, and Fuse would like give us the tools that we needed to handle a Unix socket, but I guess that's just not the case. But it does seem like it gives us the tools to handle reads and writes with some sort of like uniqueness. The direct IO flag definitely is helping us there. So I think that we've kind of like done the investigation we need to like get the thing that we want out. Oh, I did want to check. So did we... on get adder here, I just want to make sure that if we don't do this anymore, if that still works. So here we were saying that we set the size to 999 to make the read happen. I just want to see if we don't do that. If now that we've enabled direct IO, yeah, that's working fine. Okay, sick. So I guess this is why sometimes I should fucking read docs, right? Just like that helps. And so I've definitely done that sometimes where like you like get a new library and you just like, sometimes it's just good to just read the whole doc set once, because you'll just have these like clues in your head of like, oh, I've seen that word before and that word will help me. And if I had done that here, then I sure would have got to the answer here faster. But yeah, it's fine. It's fine. So I think I'm going to call it there. I'll come back tomorrow and actually do the item creation part that we wanted to do. Thanks for watching. If you liked what you saw, I stream most days around 1 or 2 o'clock Pacific time for 1 or 2 hours. If you miss stream, then there's a YouTube link in the Twitch description where all the VODs will go up. And if you're watching on YouTube and you want to come swing by and say hi, there should be a Twitch description or Twitch link in the YouTube description. There's a GitHub link and a Discord link in the Twitch descriptions. GitHub's where this code will eventually end up. And Discord is for if you want like notifications a little bit ahead of time when I'm going to go live. I post in there maybe like an hour or 2 before stream most days and just say like, hey, this is what we're going to be doing today, as well as if you want to like chat about whatever while we're offline. Yeah, I think that's all I've got to plug. Thanks for watching, and I'll catch you guys on the next one. Bye!